Hello everyone, hope you all are doing well. So I'm back with another Leetcode Daily Challenge and it is Leetcode number 133 clone graph. It is a medium level question and I also feel the same. Okay, so the question is given a reference of a node in a connected undirected graph. Return a deep copy clone means deep copy means a complete clone of the graph. Each node in the graph contain a value int and a list node of its neighbor. This is the structure of every node. It is given something like a tree kind of. It is not given in adjacency list or adjacency matrix. It is given uh, a, reference to the node of a reference to a node. Okay, so a node contain its value and all its neighbor which it is connected. Okay, for example, if you see so I will explain this in the explanation. I will take the same example. So for example, let's take this graph. Okay, so this is the same as example number one, and you see that here I have write down some numbers like 100, 200, 300, 400. Okay, so let's say the node 1's address is 100, nodes 2 it's 200, and node 3 and 300, and node 4 is 400. So you guys may think like I will just return the same node again. Okay, so but it will give you a wrong answer, because you can see here in the example number one they said you cannot return the same graph. Okay, and you also cannot mess up the graph. Okay, the order must be maintained as same as the original graph, so you cannot return. So that's why I have write down this addresses to make you very clear that you cannot return any of them, because if you return uh, let's say they provide this node, okay, this one with address 100. Okay, then you return this node again, so this will match, and the driver will know that you are returning that simple that node only, means that original graph only. Okay, so it will give you a wrong answer. So what we have to do, we have to create a complete new graph. Okay, so for that we need a map. Okay, that is node star against node star. Okay, because node star is the type of this node. Okay, like you can see here. And uh, what the first node star contain, it contain the original graph or original graph node, and the second node star will contain the duplicate. Okay, the duplicate of this graph which we are going to create. Okay, now as I told you, the structure is something like you are given an, if this is a node, this is its value, let's say it's one, and it, for this example, it contain two child all the way, so there will be two child. Okay, for one node, that will be that will be two and three. Okay, so this is the structure of this node. Now how we will do, you can do either a DFS or a BFS, but I will explain the BFS part and you can try out the DFS. It is quite easy if you understand the BFS one also. Okay, so first of all, I put this element inside my queue, this first element inside my queue. Okay, it is one. Then okay, then I put this two inside my map. Okay, so it is one, and there is two child of it. Okay, it is two and three. Okay, I just simply put that node inside it. Now I I will again create a copy of this. Okay, deep copy. So I will create a node. Let's say it is, again I create a node one, and it also contain a vector as the structure given you as a vector list of node type. Okay, and in C++ it is a vector type. So I just simply do this. Okay, so initially these two vector this vector have not any value, so it is the final form. Okay, then I pop this one out. Okay, I just simply pop this element out, and I check its adjacency neighbors. Okay, so its neighbor are 2 and 4. So again I check if 2 is there in the map. No, there is no 2. So I will insert 2 here, and I will update means this 2 is the original. Okay, so it already contain its childs, okay, like its neighbors. So it is 1 and 3. So let me put here 1 and 3. Now I need I need to check if this is as it is not present in the map. It is not present, also not present in the queue. So I'll put this node in the queue. The queue type is also node star. Okay, it is also node star type queue. And mm, again, then I check. Then I just simply put this. For now, our current element is 1. Okay, current is 1. So now I just simply puts its neighbors into our copy. So as I created 2, I will put 2, and then there is one more node here. It is 3. So I will put 3, and it's also contain a value of 2 4. So I just simply update the next to 3. Okay, so the first node is created. Then, and I also put this inside the queue. Okay, so the updation of this element will be done every time, but you only put the element inside a queue whenever you find that that node is not present in the map. Okay, because if it is already present, then it means that you have already visit that node. Okay, for example, now when I travel back to 2, then if I found a 1, so but 1 is already present na, so it means that we have already visited. So we need not to visit that again, otherwise it will give you a daily. If you if you not track of that the element is visited or not, you will get a TLE. Okay, now second is 2. So I'll pop 2. Okay, now I check if okay, so I pop 2 and I check its neighbors. So it is 1, and it is again it is 3. Okay, uh, but as you can see here, as 2 is not created, as you can see here you have to create it all its edges with a proper connection. Okay, so I hope you understand what I mean. So what you need to do, uh, one thing I just missed, that if you inserting this element inside, then you have to also create a copy of that element. Okay, whenever you insert it. Okay, that is when I just put this 3 into the node, I also have to put this. Okay, inside my uh, inside this also, and just leave this as empty vector. Okay, now when I process 2, I can see it is 1 and 3, and 1 is already present, and so I will not push the 1 again. So I just simply update my 2 1. Then I again and I is again means 2's next is 3. So 3 is already present, so I will push here uh 3. Okay, I will not push into the map. I just update my this nodes vector, and I just push this element. Okay, now after this step, this was looking like 1, this is 2. Okay, and yeah, there is again 3, and 1 is going to 3. Okay, 1 is again going to 2. Okay, oh sorry, I just made a mistake, I think. Okay, actually it is 4, so this is not 3, this is actually 4. Okay, and this is again it is a 4. Okay, so I have taken 3, so let me take it as 3. Okay, I just update this element to 3, and this element to 4. Okay, now this 2's next element is 4. So I just check if 4 is present here or not. So it is not present, so I'll update this. I will create a 4 here. Okay, and push this element, and its child is 2 and 3. So it is the original, so there it must be present. So it is 2 and 3, and here also I make a copy of it. Okay, now the here just 4 will come. Okay, not 3. Here also 4 will come. So 4 is, as I insert it in the map, I again insert it in the queue. Okay, then the 2 is completely processed. After processing, the graph is look like something like this. Okay, uh like it is 1 is pointing to 3. I have created the complete one. 1 is pointing to 2, 2 is pointing to again 1, and 1 is then 2 is pointing to uh, where it is pointing to 4. Okay, so this much edges will be there. Okay, till now we just process 1 and 2, then I process the 3. Okay, then my current is 3. So I will check if 3 is neighbor. What are the 3 neighbor? It is 1 and 4. It is 1 and 4. Okay, as I updated my graph, it is 1 and 4. So it is 1 is present. Yes, it is present, so will not push into the queue. I just simply update it. Okay, then this means like there is a edge from this 3 to 1. So I will do this 3 to 1. Then again, is there 4 is present in the map? Yes, it is present in the map. It means it is also present in the queue, otherwise it is visited. Okay. Then I just simply put update my this to 4. Okay, it is 4. Now it means that there is a edge from 3 to 4. Now then I pop the 4. Okay, and for a neighbor is 2 and 3. Okay, so is 2 is present in the map? Yes, it is present. And uh, then I just simply update it. Okay, like it is 2, and it means that there is a edge from here to here. Now is there 3 is present in the map? Yes, it is present. Okay, then it will be this, and it is okay. So you are successfully clone this bidirectional graph is nothing but an undirected graph. Okay, so it means you have created a node successfully, this node successfully. Now this is and its address will be something different, like let's say it is 1000, 2000. It is completely a new node we will create. Okay, it is 3000, and it is 4000, let's say. Okay, so let me show you the code. Okay, so it is the this is the code. I have checked if my node is empty. If it is null, then I just simply null. Otherwise, I will take a map and a queue, and I just push my first element to the node, and also push my first element to my map, and create a new. Okay, create a new node like this one. As I have created, when I created the first one, I also created this here also. Okay, and this is the similar as the input which is given. So the initially these 2 and 3 are present, and this is empty. As I told you to keep it as empty, so I have taken an empty. Then I iterate the whole queue. Then I just pop out my front element, and I check pop out every element and check if its child. Okay, where its child is present, its child is present in this array. Okay, in this array, so in this part. So I just iterate through that array. Okay, means this neighbor is the array, and I just check if my that element is already present in the map or not. If it is present in the map, it means that I have already created that node. Okay, then I just simply updated my that maps neighbor. Okay, with the child. Okay, so so this is it, and after that I just return my final node. Okay, so it seems bit a confusing problem. Okay, just you need to handle such cases. Okay, like you have to keep in mind like what is the process. Okay, so it is completely algorithm, so you have to understand it, otherwise it will be very hard. Okay, so let me submit the code. uh, okay, it is accepted, and I will provide this code in the discussion in the description box, so you can check it out there. So hope you understand this code, and I will see you tomorrow. Till then, goodbye.